this video, let's do this example. So this is a problem in real analysis about sequences, and it says assume that the sequence 1 plus 1 over n to the nth power converges to e, which is a true statement. What are the limits, if they exist, of the following sequences? Prove your answers. So the first sequence is 1 plus 1 over n squared, all that to the n squared, and then the second one is 1 plus 1 over 2n, and then all raised to the nth power. So take a moment and try to work on those. Okay, let's go over the answer. So let's just make sure we understand what's going on here. So when you have a sequence 1 plus 1 over n to the nth power, what that's saying is, so here's the number line, and you take, say, n equals 1. So if n equals 1, then it's 1 plus 1, which is 2, right? So this is an equals 2. So this is when n is 1. So a1 is 2. So let's say this is an. Then you have a2, which is 1 plus 1 half squared. That's like something here. So it's like a2, then a3, and it turns out that they converge to some number. Well, the number e, right? The an's converge to e. So when you see 1 plus 1 over n squared, okay, to the n squared, that is a subsequence of the original sequence, because you're looking at specific n's. So for instance, you're just looking at when you have 1 plus 1 over n squared to the n squared, okay, that's going to be the sequence consisting of, well, it's going to be what you get. So when n is 1, right, you just get a1. When n is 2, you get a4. When n is 3, you get a9, etc. So this is a subsequence of an, of the sequence an. And we're assuming that the original sequence an converges. So what do you know about if you have a convergent sequence, what do you know about every subsequence? It converges, and it converges to the same limit. So since this is a subsequence of an, hence the sequence, I mean, this is really just an squared, right? Hence the sequence converges to E. So that's the answer to part A. And then the answer to part B, okay, so you have this. So, you know, here generally what you want to do is you want to try to modify, you want to compare the sequence that you know converges to E to the sequence that you're trying to work with. So here you have, you know, 1 plus 1 over 2n to the n. How do we make it look like the sequence above? Well, this is, use the fact that this is 1 plus 1 over 2n to the 2nth power, except the square root, right? Because it's 2n to the, it's to the 2nth power and then to the 1/2 power. Now this, again, this is a subsequence. Okay, this part. That part is a subsequence. So you could say something like sequence bn, which is 1 plus 1 over 2n to the 2n. Again, this is just a subsequence of the an's, where you just look at the even numbers. So this is a subsequence of an, so converges to E. And again, we're using the theorem that says that every subsequence of a convergent sequence converges to the same limit. Okay, so since the inside term converges to E, what does the square root of that converge to? It converges to the square root of E. So this sequence converges to the square root of E. So that's the answer. Okay, so basically for this problem, the idea is you want to have some familiarity with how to work with these sequences, how to match one sequence with the next one, and then you want to be aware that of when you have a subsequence. So for instance, A was just a subsequence. B, okay, you have to do a little bit of, you have to recognize that, oh, I have this mismatch between the two n here and the n here. And then you have to know that you can just do some algebra to rewrite it like this with the square root, and then you recognize that the inside O, that's a subsequence, right? And then you have, so that the subsequence converges to the same limit, and then you have the square root, and it converges to the square root. Okay, so that's the answer to this problem. Oops. Nope, that's not what I want to do. How do I turn this off? Please turn off